Hi, today is 6th July 2020 and from today exactly 144 days is remaining for CAT 2020. So today I'm going to discuss three questions from number system, a very interesting question. Alright. So there are three questions 19, 20 and 21. So you can pause the video, spend around 5 to 6 minutes, try to solve all these three questions. In case if you're not able to understand it, then you can see the videos. Okay, now let's start. The first question here, it says define a number to be smart. So there is a number to be smart. That is the definition here. If all the digits of the numbers are same. So if all the digits are same. How many positive numbers less than 10,000 are both prime as well as smart? So basically we are looking for the numbers which are both prime as well as in which all the digits are also same. So it's a simple counting technique, an easy one. Now, so let's see here. First of all, we'll think how many single digit number are there. Okay, single digit number are there. So if I'm talking about a single digit number, so it can be either 2, okay, or 5 or 7. And there is one more, that is 3. So there are 4 prime numbers, that is 2, 3, 5 and 7. So these 4 numbers are definitely satisfying. Okay, they are both prime as well as smart. Okay, so they are satisfying. So these are 4 values. Now, let's see if it is a 2-digit number. Now, 2-digit number in which all the numbers are same. Okay, so we can say as well as prime. So one of the number is nothing but that is 11. Okay, 11 in which both the digits are same as well as nothing but this is also a prime number. Now, what about the remaining numbers? Can I say all the 2-digit number in which both the digits are same? Like if it is in the form of AA. And if it is in the form of AA, so this can be written as nothing but that is 10 times A plus A. Why units place and the tens place here? This is at the units place and this is the tens place. So this will be coming out to be equal to what? 11A here. So all the 2-digit number in which both the digits are same, it is always a multiple of 11. So if it is a multiple of 11, can it be prime? No. Only when A is equal to 1. When A equal to 1, so in that case both the digits will be same and it will become 11, which is a prime. So there is only one value when there is a 2-digit number. So there is only one value here. Now, next if I am talking about a 3-digit number. Now we are looking for a 3-digit number in which all the 3 digits are same as well as all these 3 numbers are prime. Now I can say what? It's a 3-digit number, so hundreds place we have got A, tens place also A and units place also A. So this is equal to 111A. And 111A, it is equal to nothing but 3 into 37 into A. So 3 into 37 into A, can it be prime? No, it will be always a composite number for all the values of A. Because this number can be written as a product of two numbers 3 into 37 and there can be one more number. Even if A is 1, it is 3 into 37. So you can say it is always a multiple of 3 or a multiple of 37. So it can never be prime. It is composite number. Now similarly if I see 4-digit number. Now 4-digit number, I can say all digits are same 4 times A. And if all of them are A, so similarly I can say 1000 place we have got A, hundreds place we have got A, tens place also we have got A and units place also A. So this is equal to 4 times 1 into A. Now what about 4 times 1 into A? 4 times 1 into A, that is equal to 11 into 101. So if you factorize 4 times 1, it is 11 into 101 into A. So again it will be always a composite number as it is a multiple of 11 as well as 101. So, and since we know that we need to find out the answers for less than 10,000. So less than 10,000, it can be either single digit, 2 digit, 3 digit, 4 digit. Okay. So what is the total number of solutions? 4 here and 1 here. So the correct answer for this question is 5. So 5 is the correct answer. So I hope that it is a clear. So it's a very simple question, not a very difficult. So such type of question usually comes in the CAT, which doesn't need any hi-fi funda. Now, let's talk about question number 20. It says, how many integers between 2 and 100 inclusive, so I need to include 2 and 100, cannot be written as m into n, where both m and n have no common factors and neither m or nor n is equal to 1. Okay. So basically I need to write down some number as a product of, let's say that number is equal to k. So we should not be able to write down this as a product of two numbers, that is m into n. Okay, where m and n, they are not equal to 1. Okay, not. And also, what about there is no common factor between m and n? So it means m and n are co-prime to each other. There is no common factor to each other. M and n are co-prime to each other. So we need to count how many such numbers are there. So straight away we know one fact, that prime number can never be written as a product of two numbers in which none of the number is 1. Like if I take a prime number, for example 5. Can you write 5 as a product of two numbers in which both the numbers are greater than 1? No, that is not possible. Okay, so 5, it will be written as only 1 into 5 and there is no other possibilities here. Okay, but we know that m and n, none of the numbers should be equal to 1. So if I take any prime number, it can be only written as 1 into p. So one of the factor is 1. Okay, and but we are basically not allowed to take the number in which the factor can be 1 here. M and n should not be equal to 1. So count all prime numbers. So how many prime numbers are there in the range 2 to 100? So the total number of prime numbers there are 25 prime numbers. Okay, so there are 25 prime numbers between 2 and 100, including 2 also, So between 2 and 100, including 2, there are a total of 25 prime numbers here. Alright. Now, but then is there any other number which exists? Any other composite number? We need to think about that also. So now, if you take any number of the form p square, now p is nothing but that is a prime number. So if I take any number of the form p square, so it can be written as only p into p, because it says that none of the two factors should be equal to 1. When I'm writing this number as a product of two numbers, none of the two factors should be equal to 1 and there shouldn't be anything which should be common between these two here. So again, p square is not satisfying this criteria because here p and p, both of them are coming out to be, there is something which is common between here. So like I can say 4, 2 square, which is equal to 4. 4 is written as 2 into 2, or it can be written as 1 into 4, but 1 into 4 it is not allowed. I cannot take 1 and 4, as well as 2 into 2 also not allowed because there is something common. So it means 2 square is also not satisfying this criteria here. Okay. So we can count how many numbers till 100 are there which are in the form of p square. So how many numbers are there? Let's count here. That is 2 square. Okay, 3 square. And at the max, I think it will be equal to, okay, 5 square. I only need to look for the square of prime numbers. So 2 square, 3 square, 5 square and 7 square. So there are 4 numbers here. Okay, because next 11 square, it will cross 100. 11 square is 121. So that is not possible. So none of these number can be written in the form of m into n, where none of the number are 1 and none of them are, both of them should be co-prime here. So there are 4 such values here, 4 values more. Similarly, any number which is of the form p cube will not satisfy. Why? Because if I'm writing down p cube, so this number can be written as 1 into p cube. Okay, or it can be written as p into p square. Only 2 ways. So 1 into p cube, here one of the number is 1, but I can't take that number. Here p is common between these two numbers. So count all the cube of prime numbers. So that is 2 cube and 3 cube. That's it. Okay, because next prime number is 5 and 5 cube will cross 100. So that is not allowed. So here there are 2 values. Similarly, I can say p raised to power 4. P raised to power 4 it can be written as only 1 into p raised to power 4 and then p into p cube and then p square into p square. So in this case, first case, one of the number is 1. In this case, there is something which is common between both m and n. Here also p square is common between m and n. So it is also not satisfying here. Okay, because the question is cannot be written. So these p raised to power 4 cannot be written. So 2 raised to power 4 and 3 raised to power 4. So again, there are only 2 values. Both 2 raised to power 4 and 3 raised to power 4 is less than 100. Then number of the form p raised to power 5. Okay, so p raised to power 5, I can say that is 2 raised to power 5 only. Alright, 2 raised to power 5 is 32. So there is one value which is in this form. Then I can say p raised to power 6. That is 2 raised to power 6. Again one value. And then p raised to power 7. So there are two values here. 2 raised to power 7 and that will be equal to one value. 2 raised to power 5 is 32, 2 raised to power 6 is 64, 2 raised to power 7, 128. So this is not satisfying. So do not take this number, only till 2 raised to power 6. Any other composite number? No. If my composite number is made up with the help of two different prime numbers. Okay, like if I say I'm taking a composite number like let's say 6. Okay, 6, which is 2 into 3. So in case question says it cannot be written as m into n where m and n have no common factors. But here we can write down this as what? 6 is equal to 2 into 3 and there is no common factor here. Okay, the question is which cannot be written, but this number can be written as 2 into 3 and there is no common factor. Alright. So this is so the rest composite number is not like if I say I'm talking about 12. So 12 can be also written as 3 into 4 where both the factors are greater than 1 and again there is nothing common between these two numbers. So what is our answer? So we can count our answer just here. 25 plus 4, 29. 29 plus 2, that is equal to how much? 31. 31 plus 2 is 33 and then 34 and 125. So the final answer of this question is 35. So this is the answer. So I hope that this is also clear to all of you. Now let's move to the next question. Question number 21. It says find the smallest positive integer n such that 107n has the same last two digits as n. So there are two numbers. One of the number is 107 into n and the other number is n. And both have the same last digit. Both have the same last two digit. So if both the number have the same last two digit and I need to find out what is the smallest value of n. So both the number have the same last two digits. So what about the difference? If I take a difference, that is coming out to be 106n here. And can I say this number 106n, the difference between these two numbers is nothing but it must be divisible by 100. Why? Just see here. If there is a certain number like if I say that is A, B, C and D and D and there is a number like E, D and D. So remember the last two digits of both the number is same. But when the moment I subtract this, the last two digit will be comes out to be 0. Because for the two numbers, if the last two digit is same, so whenever you take a difference, it is 0. Like I say 32155, maybe 355. In both the cases, the last two digit is same. So what about the difference? The difference is nothing but that is 1800. So their difference will always ends with 20. So it means the difference must be divisible by 100. Which means 106 into n, it is divisible by 100. It must be a multiple of 100. Now, so if I cancel here, this is 50 and this is equal to 53. Now, 53 is not divisible by 50. But since we know that the numerator is perfectly divisible by 100, so for this to be true, n must be a multiple of 50. So I can say n must be multiple of 50. Must be multiple of 50. If it is a multiple of 50, then only this 106 into n is divisible by 100 here. So what is the smallest value of n? So the smallest value of n is nothing but that is equal to 50 itself. Alright. And you can cross check here, that is 50 and the other number will be 107 into 50. What is 107 into 50? That will be comes out to be 0 and 107 into 5. 7 5s are 35. 5 carry over is 3. 5 into 10 is 50. That is 5350. So this is 5350. This is 50. If you take a difference, it will be comes out to be 5300. And 5300 is perfectly divisible by 100. Okay. So the correct answer for this question is 50. So I hope that this is clear to all of you. Alright. So that's all for today. We have also started our free webinar So you can get the information about our free webinar which we conduct every week on our WhatsApp group and the Telegram group. So you can join our WhatsApp group and Telegram group, the link of which is given in the comment section or in the description section. Thank you.